just to recap where we were when we left off, we had just gotten the ball working. As we can see, when we run the game, it bounces correctly off of walls and ceilings. And we accomplished that using the bounce function of the vector3 class. What we're going to do is actually use another function from the class vector3, so control and left click. We're going to scroll down, and it's called rotated. Rotated takes an axis and an angle, and it returns the result of rotating this vector around a given axis by angle in radians. That's important, we'll talk about that. The axis must be a normalized vector, we'll talk about that. See also global scope deg to rad function. So again, I'm bad at math, so I do not know all the details, but there are two ways to calculate kind of the angles inside of a circle. You can use degrees that you're used to, like 15 degrees or 90 degrees would be a right angle, or you can use radians, which is a float that goes up to 3.14 for a full circle, which would be 360 degrees. And there are different reasons to use each one, but a lot of places in the engine will specify if it's radians or degrees. If you mix this up, you're going to pass like the whole number 15, which is, 5 full circles, to it as a radian, when you meant 15 degrees, which is only part of a circle. So anytime you're doing rotation and using angles of any kind, verify if it's radians or degrees. Now, there are math functions built into Godot that will make it very easy to fix this problem. Remember that we replace the function call with the return value, so this lv.bounce col.getNormal, all of that gets replaced by what bounce returns, which is a vector3. So all we're going to do here is go dot rotated, and we're going to do vector3.forward. And that is because we want to rotate around this blue z-axis. We want to rotate this way. And so that's why we're going to put that as our up axis. Then we're going to do comma. And then we need to put the radians that we want to bounce by. If we put 15 here, that's like 5 circles. If we put 0.15 here, that's some subportion of 3.14, but I'm not doing the math. So what do? We do deg to rad. And then inside of that, we put what the degrees would be. So if we do like 90, that'll give us a right angle converted to radians. We'll control and click this. Go over here, it returns a float, converts an angle expressed in degrees to radians. That's all it does. It's available everywhere. You don't have to access it through a class. It's just kind of a global function to help you do math. So if we run this, we're going to see that when we bounce, we're going to take the bounced result and then do a 90 degree off of that. So you see how it shoots straight down, straight up. That's not what we want, but it's just kind of proof of concept. We could bring this down to like 15 degrees, and that would be a much nicer, smoother thing. We could also angle it like 5 degrees, and we'll get shallower angles, which could be what we want. The whole point is that we want to be able to tweak this, and now we can. This script is pretty much done for now. We're going to start moving on to other things like the paddles, and so we want to do one last pass over this to clean it up. What does that look like? We don't want to do any magic numbers. Magic numbers are pretty much any numbers that you write down and just hard code into the system, like this 10 or this 1 or this 5. We don't want to do that. We want to make variables for those things so that it's easy to see what the actual math is, regardless of what the specific number is. If you use magic numbers, you will run into problems eventually, where you're trying to solve a problem, trying to make a change, and you only change it in one place. It's a mess. So when you're done with your script, when it's working, now we can go through and clean it up. So the first thing I think we should do is probably come up with a speed value. So we're going to create a variable speed. And it would make sense to make it an int and make it equal to 10, and that would be fine. And then we would multiply the x value of all these vector3s by 10, but that's more code than we need to write. Okay, but there's actually a better way to do this, and that's what we're going to do. So we're going to take, instead of an int, we're going to do a vector3. We're going to do that equal to a vector3 constructor for 10, 1, and 0. Now, the reason that we're doing 10, 1, and 0 is because 10 is going to be our back and forth left and right speed. And 1 is going to be our up and down speed, that y. And then 0 is our depth, which we never want to move on that axis. So if we use this in simple multiplication for our other variables, like velocity or last velocity, and we multiply it by speed, the x numbers are going to get multiplied together, the y's are going to get multiplied together, and the z's are going to get multiplied together. So the z is always going to be 0 because it's going to get times 0. The y is always going to stay as 1. So up and down will move less than left and right. And then our left and right will be the fastest. It'll be 10. So when we come in here, we can just do velocity equals speed is totally fine, probably. Let's find out. Okay, and then we don't want to do any multiplication down here because it will carry over between frames, stack up every frame, and hit crazy speeds. We'll do it just for the example. If we were to put times speed here, you can see it just gets out of control. Okay, so let's remove that example. And the last thing we want to do is this here. We want to have a better place to manage it than in the middle of the logic. We don't want to be doing any changes to numbers in the logic. We want to do it at the top where the variables are easy to see and name and control. So up here, we're going to do var bounce angle modifier. And we're going to do that equal to the deg to rad of 5. Now this 5 is what we're going to change. And then come down here and replace. Okay, everything should work exactly as it did before. And now, if we want to change the speed or the angle, we don't have to read any of our code. We don't have to read any of the functions. We just see we have a speed up here. We make it 2 times up and down. We can change it to 50 degrees. And then we can click it. And now it's going to act weird and do weird stuff. It is now very customizable without having to dig through the actual functions. Now there is one more thing that we can do here, something that I do not often do unless I'm testing. I usually do testing and then hard code the stuff at the top. But if we wanted to do export, this is called a decorator. It uses the @ sign and then export. And what it does is it tells the engine to put this in the inspector over here on the right. So now when we go to ball, we're going to have a speed and a bounce angle right here that we can mess with. So now if we wanted to change the speed of this ball specifically, we could put it here. This is apparently showing up in radians, which we'll fix in a minute. And we could put this as 0.01. That's our angle modifier. And as you can see, we still mess with it. So then we can return that to normal, and that's great. So it's radians, and we want to mess with degrees. So real simple, we'll just change the logic a little bit, right? We'll take this and we'll make it an integer. We'll leave this as 5, remove the deg to rad, and we will put the deg to rad down here. So now when we go to the ball, we've got whole numbers, and isn't that wonderful? We'll go 90, we'll go 10, and we'll see what we can work with. Fantastic. It's kind of silly, the examples, but it's half the fun of game dev is the bugs. Now, it's important to remember that this bounce angle is a modifier after it's already bounced. So the bounce is doing the calculation initially for a very clean, smooth bounce. And we're tweaking it because we want to go harder or softer or whatever. So keeping this number under 45 is probably the play to get reasonable results. So we're going to look at the script. We've got 2 export variables. In our ready function, we are setting our velocity to our speed. In our physics process, we are doing our last velocity equals velocity because it tends to get set to 0 on move and slide. Bounce will take last velocity as an argument. That argument is a vector 3. Inside of bounce, we are getting the last slide collision. If it exists, then we will bounce the vector 3 using the normal that we collided with. Then we will rotate that whole thing based on the bounce angle modifier. If we don't hit anything, then we just keep going the way we were going. So does that satisfy if hit a paddle or walls bounce opposite direction at question mark angle? It does. So we delete this comment so it does not rot in the future. You can also get rid of these passes. They're just noise at this point. Fantastic. So this is our cleaned up script, and we are now ready to move on to the next thing. The next thing is probably going to be these paddles. They need to move up and down, but they need to not intersect with the walls that will stop them from moving, right? So we need to rearrange our scene just a little bit before we can actually do anything useful. Let's see if we just move these up a bit. Now, we will eventually calculate an area behind the paddle that causes it to stop the ball and restart the point and that sort of thing. But right now, we're just going to Control D and make some big old walls. Okay, this should be fine for testing. Again, the goal is just to get the paddles moving. Paddle, we're going to go into the scene. We're going to add a script. It's going to be called paddle. Fantastic. Starting from scratch again. In our classic style, we're going to go back to Excalidraw to figure out exactly what anything means before we even start coding. So this is going to be for paddles. Okay, so they need to input to move up and down. They need collision. Do they need to only collide with the ball? I think they need to stop at the walls too. So balls and walls. And then this is also where we need to invert. It seems super simple. Why go to the whiteboard just to figure out these three things that are obvious? Specifically, writing things down takes things from the realm of infinite possibility and makes them concrete. When they're concrete, we can work on them. So that's why we do it even for the simplest of things. Input, collision, and invert the input. Simple. We'll start with the collision. I think we already have it kind of figured out. We've got collision shapes. Why do we have two collision shapes? Static body. See, I don't think we need the static body. I don't know why we had extra static bodies, but we did. So it's just a character body 3D, a mesh instance, and a collision. Simple enough. Input W and S to go up and down. Invert on collision. Now, because this is a character body 3D, we get access to all the basic things that ball had, like velocity, like move and slide. We can do a lot of the same stuff. We'll probably set it up with a speed as well. And that'll make this really super simple. So physics process. Okay, and then our initial velocity, we're just going to set it roaming so that we don't have to worry about it yet. We don't have to worry about input. We're going to make the X 0. We're going to make the Y -3, and then the Z is also going to be 0 because we only want our paddles to move up and down. We don't want them moving side to side or back and forth. So we'll throw that in. They move, they collide, it's beautiful. All right, so there are three ways to handle input. One is in the input function. This is every time a button is pressed, this function will be called like it was processed. So you could do like, if that event is up, then we can set the velocity. That will run every time that you push any button or move the mouse or anything like that. Any input event will trigger this function. It won't trigger if you're not pressing anything. That's one very desirable way to do input a lot of the time. Another way is unhandled input. Input events in Godot are handled in kind of a predictable format throughout the scene tree. I believe they start at the bottom and go to the top. So if another node catches the input and marks it as handled, it will not go any deeper. This would be like if you had a pause menu and you wanted to capture the escape key. You would have the pause menu handle it first so that it doesn't open the pause menu. Does that make sense? So if you want to do things, if this, unless anything before it catches it, like maybe the interact key versus attacking, you would do that in unhandled input. But that's not really what we want. That's not really relevant to what we're doing. And the third is called polling. Polling is where you just go into like physics process or process and you manually check if anything is pressed. So you'd be like, is the key pressed? Is the key pressed? Every process function. A really common mistake for beginners is that they put all of their input in physics process because it seems like it won't run that often and we need to check it all the time anyway. And eventually they realize that they've kind of oversaturated that one frame of physics rather than running in idle, the normal process function, or the input function only when something is pressed. So for a small game like this, we can get away with putting it in physics process, but there are other ways to handle other kinds of input. The input function, if you want to do it anytime a key is pressed, unhandled input if you want a hierarchy of consuming that input, and then polling if you're lazy and you just want to get it working right now. We are going to start with input, and if it doesn't give us any problems, that'll be great. So the input function, we're going to do control and click. We're going to read about it before we use it because we're not big dum-dums. Called when there is an input event, the input event propagates up through the node tree until a node consumes it. It is only called if input processing is enabled, which is done automatically if this method is overridden and can be toggled with set process input. To consume the input event and stop it propagating to further to other nodes, viewport.setInput is handled can be called. For gameplay input, unhandled input, and unhandled key input are usually a better fit. They allow the GUI to intercept the events first. So it looks like all of that applies to input as well. What it means by set process input is that if we look over here in the inspector under process and mode, we can actually pause things and tell them whether to act or not, whether to run their process. And it's a little more advanced. It usually doesn't really come up that much unless you're doing very specific things. I think for this game, since we're not going to have a lot of menus and there's not going to be like pausing or anything like that, we're just going to use input. It seems totally fine to me. Now with the input function, we get one argument, which is the event input event. So let's see what an input event is. Properties, device, what methods do we get as text? Get action strength, is action pressed, is action released? So we can check a bunch of bools, a bunch of flags about the event. To go any further with this, we kind of need to understand how input events are set up in Godot. One way that you can handle these input events is to go up here to project settings and then the input map. If we show built-in actions, these are kind of the preset built-in ones. You can get rid of them. But very simply, just like UI up, left, right, down, kind of presets these for you both on keyboard and on joypad. And what you'll see if you try to add a new one is, let's say we want to add the action up. It'll give us a dead zone, which is useful for gamepads, so it doesn't get detected under a certain threshold. And then this plus sign will let us add an event. Now the name of the action is up, but we can add as many buttons as we want that count as up. So in this case, we're looking for W, right? We don't want to do Alt, Shift, Control, any of that. So we're just going to go OK. And now W and up. So we can come in here and we can put if event is action up, then our velocity will be +3 on the Y, and otherwise it'll be -3 on the Y. Now this is important to understand. This only runs when there's an input. So if I move my mouse, right, it's not going to detect up, and it's going to move the paddle down. If I don't press anything after pressing up, then it's just going to move it up forever. So let's run this. Okay, so it's down. I press W, it goes up. I move my mouse, it goes down. But that's not what we want, right? We want it to only change the velocity to up when we have pressed it. If we control and click, we can see that there are a few different ways to check for the action. So is action is any action that matches the up key, which in this case is W. But we can also do is action pressed, which checks for both the action and if it's pressed down. We can do is action released, so it only happens when you let go of the button. All of those are useful in different contexts. For this game, it just doesn't matter that much. But we do want the velocity to stop if we let go of a button, right? So what we're going to do here is if event.is release. This is generic. There's no specific action for this. This is any action that is released. Then we'll do velocity equals vector3, 0, 0, 0. Okay, so now we will implement the exact opposite. Now we can kind of play the game a little bit. It's a little weird. If we hold the button and we move our mouse, it'll stop moving, which is not great. So it's interrupting every time we move the mouse. We're not getting a steady. So to figure out if it's a mouse motion and then we can discard it, we need to control and left click into input event and see what we have here that can help us determine what type of action this is. We have is action type, which sounds like what we want. Returns true if this input event's type is one that can be assigned to an input action. And those types are input event key, input event mouse button, input event joypad button, input event joypad motion, input event. Now we're going to talk a little bit about syntax. Now we're going to talk about two really important concepts here. One is negation. All right, so we've got if event.isActionType, and isActionType returns a bool, which is a true or a false. If it's any of these types, it will be true, and if it's not that, it'll be false, which is what we want. We don't want mouse movements getting into our input function. So What we actually want to do is put the word not here. Now, this is a really important concept because if this returns a true or false, and it's going to return a true, we want the inverse of that. So we put not here. Another shorthand for this is just exclamation point. Another concept is returning early. You can see that if this is not an action type, if it's just a mouse movement, we're going to return. We're not going to do any of the code below this. We're just going to exit the function. And that is really important as you build kind of more complex functions. You'll see that there are lots of times you can save a lot of work, a lot of if statements by just getting out early. So never be afraid to return early. This is just kind of a blanket check before we do any work at all. Then we go into the button pressing, and then if nothing was really pressed, we do this. But we'll run this and we'll see if it works. So currently pressing nothing. W takes us up. S takes us down with the mouse moving. Oh, we got bumped over. That was not good. Yeah, so move and slide is screwing us. Move and slide is not going to be suitable for what we want. There are multiple possible solutions for this. We could convert to a static body. We could calculate the slides less. We could set some physics properties. What I think we're actually going to do is go over here to the inspector, check this axis lock, and we're just going to lock everything that's not Y. And that should fix our bug. It's a little hard to reproduce because it has to hit us on the end, but it should mean that we can't get pushed around. All right, so we've got input W and S to go up and down. That can go away because we've got it done. Now we want to invert on collision. Using our knowledge from our other script, we can do if get last slide collision. And then I think we made a note on Excalidraw about what functions to use for this. Input map, add, and remove. So let's try that. Input map. So let's check out the input map. We're going to grab that, control and click. Looking over this briefly, I think what we actually want to do is action add event and action erase event. I think. Adds an input event to an action. The action is up and down, and then the input event is at W and S. So we need to figure out what that looks like, but we should be able to do it. So this is somewhere that I definitely don't know what I'm doing. So I'm going to click using input event and open that up in the browser and see how we make one. Okay, so this looks like what we want. ev input event action.new, and then we set the action. Okay, I spent a lot of time trying to figure out how to remap things with the input map, and it's such a hassle, we're actually going to change our approach. All right, after some screwing around, I discovered input event key. That is the type of input event that we want. So control and click. You can see that eventually it inherits from input event, but it's in kind of a weird path to it. So it will count for what we're doing. I just had to find it and find out that it exists. So we've got echo, key label, key code, location, all that stuff. All we want to do is make a new one, assign it to a key. We'll assign that to up. All right, I actually forgot to hit the record button for the last couple of minutes. I'm not sure where we left off. But what I wanted to say is that when you find yourself copying and pasting all this, as I was about to do for the not inverted version of this, I was going to do this, and then I was going to do this, and that's just copy pasting a ton of code. It's an indicator that it's time to make a function. If you copy and paste something more than once, it's time for a function. So what we're actually going to do is come down here and make func invert, and we're going to make func assign key. And it's going to take arguments. We're just going to move the functionality that we've already written into this more useful, reusable function. Okay, so 30 minutes later, it reset my scene again. I have no idea why, but this keeps happening. So we're going to delete this static body 3D again. We're going to add the script back to paddle. And now maybe our stuff will act appropriately. Oh my God, that's annoying. So it's hard for me to tell where I left you guys off because I've just been troubleshooting for 30 minutes to find out that it just reset my stuff. Very frustrating. So let's get that out of there. I don't know what works anymore. We're just going to test it, what we have. In theory, if we collide, we'll erase all the up actions, and then we will assign G as an up key. W and S are working. Okay, now W doesn't work anymore. G does. We have successfully remapped a key. Amazing. I'm so mad right now. So on collision, we want to invert the keys. We want to make a function for invert, and what it's going to do first is input map dot action erase events for up, and we will do it for down. So now we'll have no buttons. If inverted, we want to do assign key up as key W and assign key as down. Otherwise, we want to do the exact opposite. Then we'll replace this with invert. In theory, it should totally work now. If it bounces, our keys will get inverted. And we are successfully playing the game of wrong. That's not right. That's totally wrong. I love it. I love it. Oh man. Amazing. We never set inverted. This inverted equals not inverted is just a shorthand way to say do the opposite. It's very useful for bools. So now it should work appropriately. Through some testing, we're finding that move and slide is not reliable. If you hit the ball at certain angles, it doesn't report the last collision. And that's a problem because we need it to reliably invert the controls to make it not frustrating and feel buggy and wonky. So we're going to change move and slide to move and collide. Move and collide is a little different. If we use control and click, we can go check it out. It returns a collision, but it doesn't automatically use delta like move and slide does. If we just do move and collide with velocity, you're going to see how weird it is that we move. We move really fast. And that's not what we want. We want to move smoothly over a frame rate. So delta is the time since the last frame. And over time, that averages out to give you steady, consistent timing. So we just take velocity and we multiply it by delta. And that is going to give us steady movement. Now, this is more reliable and it works as long as we're the ones moving into the ball. But we also want to get inverted if we just happen to get hit by the ball while not moving. And that currently doesn't happen. Honestly, this episode has been kind of a cluster of bugginess and problems. I've lost track of things, we've had to rewrite things, but we got there in the end. We have what looks like wrong, right? All the features are there. We just need to make them more reliable, better, that kind of thing. But that's how development is. You go down a lot of blind alleys and you find that you hit roadblocks and there are things that you just don't know, like math. And you develop one step at a time, one line of code at a time towards something better. We cleaned up some scripts, we put things into functions, and that's a good start. But in the next part, we're going to actually refactor some things. We're going to re-architect the code to be a little bit more reliable because move and collide still isn't doing it for us. We're going to set up an event bus so that when the ball hits anything, it sends out a signal and everyone can react to that however they see fit. That will be in part 6. Thanks for hanging in there. I know it's getting rough.